This is example 4 from the textbook, and this example shows how to use a JNS instruction to do similar to higher level language functions or subprogram, but the features are very limited, so it does not fully support the whole features of higher level languages though. But here is the example. So it begins at address 100 using org declaration and then load X. So the value at address X, which is 20, is loaded into accumulator, and then that accumulator value is stored back at address temp. So address temp, you will get 20, which is copied from X. Then JNS sub R. So at this moment, remember that program counter is always holding address of immediately following instruction to be executed. So by the time you reach JNS instruction, program counter is holding address of next instruction, which is store X. So remember that. And then JNS instruction works as follows. So JNSX means first the program counter, current program counter is stored at address X. That's the first thing. So current program counter is address of store X is stored at location sub R. So at sub R, at this place, it is holding address of store X instruction, and then second step is a jump to X plus 1. So it jumps X plus 1. X here is a address specified, so in this case it's a sub R. So program execution jumps after sub R, that is here. So program execution jumps into load temp 1. So before you come here, a temp value of X is stored. So load the whatever is on temp and then add, so it doubles the value, and then jump I. Jump indirect means using the address stored at sub R. Sub R is currently having a value is that is address of store X. That is this instruction. So jump I means go to that address. So sub R at that memory location, some value is stored and the jump to that address. So jump I jumps back to the store X. That is the immediately following instruction after jump JNS. So using this mechanism, JNS some label, and then at the end of the subroutine call jump I and then the label, so you achieve something like a subroutine call. But in this subroutine call, unlike high-level language, you cannot pass parameters, you cannot get return value, so you need to pass a parameter using some known location like a temp. So you need to define labels of memory addresses for receiving parameters. Similarly, when you return the value, if it's only one value, you can use accumulator. At this moment, the double the value is stored in the accumulator. So when the JNS is finished, you store the value in accumulator onto X again, so the value of X is doubled. Similarly, you call the JNS again, load the Y, store that value into temp, which is a parameter passing mechanism, call JNS sub R, and then you come back here, and then the value is doubled, and then accumulator holds that value. Finally, you store the value back at the Y location, so value is doubled, and program ends. The label loop is, I think, is typo. It's meaningless at this example. So let's see how it works. So load X and Y has 20 and 48 in decimal, but at that location, as you look up the symbol table, X is a 109, Y is a 108, so 109 is a 14, hexadecimal is 20 decimal, and the 30 in hexadecimal is 48 in decimal. That's the initial value. And then let's run the program. Then 109 is 28 hexadecimal, it's doubled, And then 10A, it's a hexadecimal 60, the value has been doubled.